Hello everyone, welcome to JD Explains, and today we're going to look into how to integrate LLMs into your everyday software. And today for an example, I'm going to pick a RPG game built using Pygame in Python, and we're going to use an LLM to generate the map of that level each and every time the player wins the level. So let's see where we can go with this. Today we're going to use the byLLM package for this. So this is byLLM, so it's part of the Jiseki ecosystem. We'll get into that in a bit. So we'll be using the byLLM package. It's a basic pip install, so you just do pip install byLLM, and then you go just and use byLLM. You can use either in Python land or in Jack land, or Jack programming language, which is a programming language which supersets Python. So it basically compiles to native Python bytecode and runs on the generic Python interpreter. So it's a very nice programming language. But today we're gonna more focus on how to integrate our LLMs through byLLM into your existing Python program. So let's look at actually the application that we'll be using today. So whoop. So now, today we're going to use a application where we have this Python game. So let me just pull this one up. Let's have open preview. Okay. So it's a Python game where you just have a person walking around and we're trying to play that game. To show you an example of this, let me just get back to the docs. And if you go to view docs and in examples, we have this RPG game with AI. So this is a very quick demo of what this application might look like. So you have a person like annihilating people on the map, and each time you finish eliminating all the enemies, then you generate the next level. And this is done using an LLM for this game right here. So this image is just for demonstration purposes. This is not what is actually happening. We'll show you what's happening. So this is a tutorial built in byLLM to how to do this. You can follow this if you want to, but today I'm gonna go on a different approach and show you a neat way to integrate these LLMs into your programs. Okay, so here we are. So now let's look at the code base. So it's very limited code base. It has this font file and some images. You can see the characters here, the backgrounds and so on. And then you have this config, which is basically a configuration file which contains the constants, config.py constants such as what is the attack layer. So it has a layer mechanism. This is part of Pygame, so it's not something that I'm going to talk about in this tutorial. It's a separate tutorial series, to be honest. So this main.py is where the entire game logic is written, which is like 330 lines of codes. So it's 300 lines of code. It's a nice game. If you want to show you a demo of like how this game plays right now, let me just first create an environment. Wait, let's say RPG. So we will create a new environment. We'll be using Python 3.12. Okay, after installing Python, the conda environment, let's say RPG, and let's pip install again. Yep. Okay, now it's just a Python program, so let's do Python main.py. Okay, give me a second. What's in main? Yeah, some modifications that I just did. So let me just remove that line. We'll just tell you what the line does later on. For now, we don't need it. We are just running the bare bone application. Let's see if I can get the app running here. Okay, there you go. So this is the application. So when you play the games, we have this person die instantly. Okay, so this basically runs through a random set of like maps that I hand created, and its players just spawning according to those maps that I created. So to show you where the maps are, so if you look into this maps.json, you can see a bunch of map objects created, right? So you can see the maps are all over here, and these maps are actually instantiating these map objects right here, and we are basically serializing each map and visualizing it using Pygame in our game. So that's basically the pipeline. So you have the main, you can go to the main, the repo is out there, so you can go to the main and actually look at the actual logic of the program, but that's not what I am interested today. So we'll be talking more about this map.py. So in map.py, you have this map object, you have the wall object, and you have the position object. So these objects are what's in the program that determines the map, and you have a set of maps in this JSON that you load. So that's the plan. Okay. So now I'm going to show you how we can integrate a LLM into doing this job right here. So, okay. So first of all, what we need right here. So we have these objects right here. So I'm going to show you Jacklang a little bit. So you'll know why I would like love to use Jacklang in the first place. So first of all, first thing that I'm doing, I'm creating a copy of this basically not a copy. Let's rename this entirely. Let's say map obj. So it's basically the map object. Skip changes. Don't make any changes. Okay. So you have the map object, which has these stuff right here, and I'm just gonna get rid of this load from and the level manager. I'll show you what I'm gonna do with those in a second. Yeah, comment those out. But I still have this. Let's get this one right here. So I have this map object. We have the position, wall, and map right here, and the serialize function is still there. Just the map loading functionality and the level manager that actually manages all the levels are like commented out right now. So I'm going to implement those in Jacklang and import it into our main.py and use it instead of the level manager that's in this map object. Okay, so we first did this. Let's get rid of these imports as well. I'll clean up in a bit. So now let's create the actual map.jack. So this is the one that's gonna be imported when we actually have in the main.py, when you have import jacklang at the top. When you have import jacklang at the top, instead of this map obj, this map.jack will be imported when you just say from map import level manager. So if there is a level manager inside this map.jack, it will be imported instead of what was imported before in Python. So let's first of all, let's import what's inside here into map.jack. So to do that, we'll just say import. So we need it from map obj. Okay, so what we need is position, yes, map, and of course walls. As I remember, let's see what we have here. So you need the wall, map, and position. So it's on walls, it's just okay. So you need the position, map, and wall. You import that into here. Okay, that's the first thing. Next, now we need to write the application, right? So we need the rest of this stuff right here. So let's bring the map object right here. Now we need to implement this level manager. So let's just do that. In Jack, you define it as obj instead of class because it allows you to natively use data classes without actually using data declarators. It's quite awesome. So we'll first have obj level manager, yes, but the syntax is different now. As let's have the same stuff which are here, which is current level used maps. Let's say current level is a integer here, and you have as used maps. So used maps, and it's a list of maps actually. Yeah. Okay, now we have the basic level manager, and we need to add the multiple classes that we need. So let's first put the def. We first have this get next tile map. So next, and which produces the map. We don't need to pass anything because it's Jack. So in Jack you don't need to pass in self. Another nice thing. So for now, let's just pass this. Okay, oops, we forgot the semicolon. So Jack uses semicolons and curly braces, and if you are this into the video, you already have seen this. So Jack is basically Python with curly braces and semicolons, and we first define this like basic method right here. So okay, let's move on to the next. Okay, yeah, it's outputting a map class. Then we need these functionalities which are like inherently there. Let's just copy those over. So okay, wait, get current level. Yeah, so get current level self. It's gonna be return self dot current level. Awesome. And def reset would be this. Will return an int. Yes. The reset will return none. We have reset. Yeah, but what the reset will do is oh, okay. So it'll basically do these to current level 0. Well, yes. So basically this is what we have here, but in Jax syntax. Cool. Now what we need to do is basically implement this, right? So we need to implement this part, which is the get next style map. That's the core of this entire endeavor. So let's get to that. So let's first so we need the LLMs. So let's go and see how the LLM integration actually works in byLLM. Okay, there you go. So in byLLM, what we need is, let me go to, yeah, you have byLLM and you have quick start. So what we need is to implement, okay, so we need to import from byLLM model. Okay, so that's the first thing that we need. So let's go here, then have this over here, import byLLM.lib. So that means I have to install byLLM. So for now, okay, so it's pip install byLLM. It's just a PyP package. Okay, now we have byLLM installed. Awesome. So we don't have any dependency issues. So we have byLLM.lib. Now we basically write this get next tile map functionality, and to do that, let's first have our LLM initialized. So has LLM equals, oh, it's a model object. Let's just initialize that right here. Model GPT. Let's say use 4.0 instead. GPT-4 is costly. So I'm gonna use GPT for this tutorial, but you can basically use anything like Gemini. The documentation covers how to use all of these APIs and also post your own local mods. So that's great with byLLM. Okay, so now what we need is the functionality of actually getting the next level, right? So let's write that right now. So in this one, we this self dot current level +1. Then we basically, let's say new map equals, which is off map, you say new map equals self. Let's have a function called def generate next level. Okay, and what we are passing is the current level. It's passing the current level, which is an integer, and then we'll be passing in used maps. So that's the LLM's generating gibberish now. Okay, I don't want any of those. So that's a way to do it if you're not using byLLM. But with byLLM, it's much more easier. So let's first have the list of maps. So it's not L, it's simple L, easy, and we'll be outputting one map. So that's the idea. I'm just gonna stop here. I'm not gonna implement it right now. I'll show you how to implement it, but for now, let's keep it at that. And get next level map. So you have the new map self dot generate next level current. Okay, use maps. Cool. And you append this and you get the new map. Okay, this is basically, oh no, so this should return new map dot serialize. So because it's returning a map object, yeah, it's actually, this is not returning a map. Let's see what this is returning. Get next style map. Okay, it's serializing. So after serialization, it's not returning a it's basically a list of strings. So let's have a list of strings here. So let's have list of strings. That's the output type. Oh, not for this one. This one is actually generating the map. It needs to give us the map. This one will return a list of strings. Okay, and we have serialized. Cool. Now the only part that's missing is how we implement this one. So how do we put an LLM in there? We just do self dot LLM. So you know where the byLLM came from, right? So if it was an LLM that's defined globally, you just say LLM. For this case, I'm having this LLM right here, so I'm doing self.llm. So generate next level, current level, blah blah blah, map by self.llm. So this is the entire application right here. I have implemented a agentic, oh, not agentic, but agent that basically generates the next level for this player. So let's see how this works. Okay, let's save this. So you have the map and you have the main.py importing the map, and you are importing the level manager and instantiating. Everything's remains the same. And let's see how this works. So we have a Jacklang installed. We have byLLM installed, and it automatically installs Jacklang as well. So if I say pip show Jack show, yep, we have 0.9.1. Pip show byLLM, we have 0.4.7. Okay, pip install. Oh, we will just we don't need to do any pip installs. Let's just rerun the application. It's running. There you go. So we have the application. Let's see, play. Okay, we have our first level fully generated by AI. This level, it's a bit different. So the level is getting bit by bit different. Okay, now we have an additional enemy. Next level. Okay, now we are playing the next level. Oh, the map's larger. We continue to. Okay. So in this version of this game, the LLM is thinking, okay, the larger the map, the harder it is. In a way, it's okay, because if the time is longer than longer to finish a level, that means you have a lower score, so that makes sense. But we can direct the LLM in different ways. A quick way, before ending this tutorial, I'll show you a quick way how you can control these. You'll just need to say, so what you'll be needing is, you'll say, so you have this position map and wall. So to have this LLM perform according to our will or the developer's intent, we can embed more semantics or more meaning in this code, because the level itself, when you say position, they might get what position is, but there is a chance it will not understand what a position is. So to give them more context, we can just say sim, we have position, so position, sim position equals, we can just say position of object slash entity in a 2D grid represented by x and y coordinates within bound. Yeah, let's just say that. Okay, that's one thing that we can say to the LLM. We are basically annotating the code. We're not actually prompting here. We're just saying, okay, this class here can represent this. So let's basically run the program again and see what happens. So what we can do is Python main. We get a new map. Okay, so let's see how this plays. It's way harder than before. Next level. Okay, I was doing a job. Let's see whether it's a good job. Oh, yeah, it is a good job. This is a significantly harder map relative to the ones that were before. So let's see. Go next level. Keep in mind the movement of the player is just random. It's not AI generated. Only the placement of that enemy is decided by the LLM, but the LLM can decide. We can give that as well to the LLM, but in this example we are not doing that. We're just placing the enemy and deciding the orientation and their movement speed and everything at runtime. So yeah, so this seems like adding that small sim string or the semantic annotation actually let the LLM do a better job. So you can basically add more sim strings in places that you feel that it's not clear to the LLM what to do. You can just add sim strings. It can be this position, it can be the generate next level. So you can basically add a sim string there by saying, say, sim level manager dot get generate next level equals something. So you can basically do this, and you can just add something to show that what this actual function actually does. So you can basically add that string here. So you can see what we did was we moved the stuff that were already there using map object. These data classes, we moved them to this map object.py. We have this re-implemented the level manager in Jacklang, which it was just simple. Most of it was like the same. You just implemented this one. Even you can even just implement that alone separately in Jack and import and use in the level manager as well. That's also allowed. but for simplicity, I just wanted to have everything in the one file so you can see. So generate next level, you define it there and use it here. It's very straightforward. You basically import and use in main.py as same as you imported the map.py. So it's a very nice integration into your existing application. So using this way, you can integrate byLLM into any application that you deem you need integration by just defining it, importing it into it, and just using it. So for an example, if you go to Python integration, you'll see that you have two methods. One is you can basically write byLLM in Python, but you can also do the thing that I just did. You just define it elsewhere and just import and use. So okay, so this is the entire tutorial for you to integrate LLMs into your everyday applications. Hoping to meet you guys with another brilliant tutorial. See you next time.